Welcome to the Air Power Airwaves, the Air Power Manufacturing Solutions podcast series where we talk about manufacturing issues that impact you. Hey, it's Travis Stirewalt coming to you live from the Air Power Live studios in High Point, North Carolina. And today we have another episode of Air Power Airwaves podcast. I have two guests with me today. I got Sam Goebel with GCI. How you doing, Sam?
Good. How you doing?
Doing good. I think this is podcast number 2 for you.
It is, yep.
All right, good deal. More on this guy later. And then I've got third time champ podcast here with Aaron Osbourne. How you doing, Aaron?
Good, sir. You?
I'm doing fantastic. Thank you. Aaron is one of our application engineers in the assemble segment of our business.
Yes, sir.
So I guess assemble and move, right?
Yeah, that's right.
Kind of like a dual role.
I kind of fit both molds.
Yes.
Kind of depending on what the application is.
All right. So let's get into a couple things here. But first, I want to say, hey, Jai. Jai's our marketing manager. He's always here making sure things run smoothly and making sure we actually capture sound the first time and don't have to do it again. If you've ever been in a studio like this, you understand how painful that is when you get done and you got to do it all over. Okay, so before we get into the details, you want to know anything about GCI, go to the airpower-usa.com website. On the top of the website, there is a button called Brands. If you click on Brands, that is Air Power's top, 50 vendors or more. It started out in top 50, I think. Now we've got a lot more. But you will see a logo for GCI there. Click on that, and it is GCI's website within our website. And if you find something on that website that you want to talk to somebody about, call 1-800-334-1001, and we'll get you some answers. Pricing, whatever else you need. Solution, whatever. They'll probably call this guy. And then this guy will call this guy. And then, my people, your people will all show up and we'll provide you a solution. How about that?
Exactly.
All right, cool. Again, Air Power Airwaves, the podcast. If you go to airpowerairwaves.com, you will find links to the audio versions of the podcast. And you can go to anywhere you listen to podcasts for that matter and find it. And you'll find links to, I don't know, but I'm going to say hundreds of videos now on our social media platforms and on our website, 200 plus videos. And all right, so Sam, who is GCI?
GCI is an engineering company. We're based in Minnesota. We specialize in engineering and material handling and torque reaction systems.
Okay.
I've been in business for 31 years. We sell worldwide. We focus on the U.S., the Midwest, and the East Coast mainly. But we have systems all over the world. We have some in Canada, Mexico, South America, Europe, Asia. The only places that we haven't sold anything since I've been there is Africa and Antarctica. So next time you are in Antarctica, let me know if there's a customer down there for me.
Man, I'll drop some leads, man. Let's go for it. I wouldn't mind going, hey, we could go and cold call for a week or two.
Literally cold call. Perfect. Yeah, so we are based in Minnesota, and we're an engineering company. So we're a company full of engineers, a bunch of geeks that like to design and put together stuff. We do everything ourselves in Minnesota under one roof. We do all the engineering work. We do all the fabrication. We do all the painting. We do all the assembly. And then we have some full-time service techs that work for us that actually go to customer sites and help with installation and troubleshooting. So the reason that we do that is we found that we were not happy with the quality we were getting from outside vendors. So we wanted to do all that stuff ourselves and control our quality. So now we have 100% control of our quality. We can send good units out so Aaron can focus on helping his other customers and not having to fix our stuff.
Fair.
Yeah. It's appreciated, by the way.
Yes.
Much appreciated.
All right. So the first podcast we did together, we had Mike Rogers with us, and we talked about material handling.
Yes.
We talked about, safely lifting heavy things.
Yep.
Or light things repetitively, whatever.
Yep.
Today, the rabbit hole is torque reactions. I guess the simplest form of thinking about torque reaction would be a wrench uh, torquing down a nut, right?
Yep. Yep.
So in this case, I guess we're going to talk about repetitive of that. We're going to talk about the beyond human strength
Yep.
levels of that, and I guess safety is probably a big factor.
Right.
Okay, so let's first get into it. What is torque reaction? Who wants to take that?
You want to explain how a DC tool works, Aaron?
So when you deal with a continuous drive type tooling, say the amount of force that you're exerting to fasten or create a clamp load is exerted from a tool, but it's also felt on the fastener, but also is felt in the reaction of the tool as well, right?
Okay.
So on the back end, so continuous drive means that, hey, that driver is going to run till it stops. It doesn't have a cam or any kind of way of reducing any of that reaction. So typically anything that's under 100 newton meters or anything over 100 newton meters is typically you're going to find yourself in a situation where you need some kind of reaction device or some way to manage that torque, right?
Is it so? There's a term that that I've heard people use in manufacturing where, let's say they're using some kind of a power tool, and you have things happen where they refer to it. Man, that thing kicks. You know what I'm talking about?
Yep.
So if anything ever kicks, it's very unsafe.
Right.
So I would imagine that a lot of what you guys do together with this segment of torque reaction is around those safety concerns. And then there's also things that you physically couldn't, bolt down to the right torque. I'm thinking like a Navy shipyard. I'm thinking,
Yep.
Big machinery, building tanks, whatever it is, right?
Mm-hmm.
Let's talk about limitations of torque.
Yeah,
What's the max? What's the min? Where are we at?
Yeah, so with a continuous drive tool, you'll typically see if somebody doesn't have a torque reaction arm on it, they're going to put a slam bar on it. I'm not sure if you're familiar with slam bars, but
No.
they go on the end of the
Sounds
tool.
violent.
And if you think about torquing a wheel lug nut, the slam bar rotates with the tool and then it reacts off the inside of the wheel rim. So for years, customers have been trying to do that. They have a big heavy tool at say 250 foot-pounds, and they're going to use a slam bar to react the tool off of the inside of the wheel rim. Well, very quickly, people understood that if you get your finger caught in there, your finger is now gone. You
Yep.
just are missing a finger. So that's not safe. So what our systems do is we hold that tool and we react the torque from the tool through the arm to keep the operator safe. So now you get rid of that slam bar, and all that continuous drive, all that reaction is going through the arm based on the geometry of the arm rather than either through a slam bar or trying to hold it there. So, like Aaron said, anything over about 100 newton meters, unless you're a pretty big guy, you're not going to be able to hold that safely. So our systems, we start at 100 newton meters and we go up to our arm line goes up to 7,500 newton meters. And we've actually done systems, specific systems up to 12,000 newton meters.
Give me an example of what would it be at 12,000 newton meters?
Internal to a windmill. The bolts that hold the windmill together on offshore windmills, the ones with 100-foot long blades, 120-foot long blades, there's a hub inside of there, and what's holding all those components together, those bolts are torqued at 12,000 newton meters.
Yeah, you don't want those coming apart.
I'm pretty sure you don't. You don't.
Especially if you're on a boat underneath it.
So our torque reaction side of the business, we do benchtop systems. We can put them on a bench right here, 70 newton meters, 100 newton meters, real small, light, easy to use. And then our arms go up to 7,500 newton meters. Our arms are anywhere up to 20 feet of reach. So a typical steel arm, if you go to 12 feet of reach, it works pretty good, pretty easy to use. When you go to a steel arm that's beyond 12 feet of reach, they get heavy, they get hard to use. So it's hard for the operator to use. So GCI is the only ones in the world go up to 7,500 newton meters utilizing carbon fiber technology. So once we get above 12 feet of reach, we can go out all the way out to 20 feet of reach utilizing carbon fiber. The carbon fiber systems weigh approximately a third the weight of steel. So they're still as easy to operate as a shorter steel arm, but it gives you that extended reach. So the advantage of this is if you have fasteners at one end of a cell and the other end of a cell, instead of having to have two torque arms, two tooling systems, double the maintenance, double the spare parts, you can have one system to reach both sides of a work cell, or maybe both sides of a line with a single arm, single tool system, which keeps your expenses down, it keeps your maintenance costs down, and then the operator doesn't have to worry about two different things to work around inside the work cell.
Okay.
Within those, all of our systems, we can do any type of fastener orientation. We can do horizontal fasteners, we can do vertical set fasteners, we can do anywhere in between.
So what
And-
you're talking about is basically how you come at the part.
Yep.
Okay.
And we can do that with any style. Aaron's going to look at an application, talk to the customer, and decide which style of tool makes the most sense for the application, for the clamp load needed, for the joints that you're torquing. And we can facilitate any type of fastener orientation within that. So whether the bolts are a single orientation, so just vertical or just horizontal, or multiple, we have ways to do that. We can go up to 6 axes of different movement to make sure that the operators can hit all those fasteners with a single arm, a single tool.
Pretty
So-
much giving you the ability to have a handheld tool
Right.
at a higher torque level, right?
So here's my question, and people are probably thinking about this right now anyway. When you talk about, we've got the reach, we've got the arms, we've got, the weight class that we know we need to be at. When we're talking about the actual tools themselves, do we work with our other vendors that supply tooling for us? And do those get integrated to the end, or is the tooling part of GCI's offering?
So that's where you need Aaron's expertise. So we are GCI's tool neutral. So Aaron can look at a project and decide which tool makes the most sense for his customer. It doesn't matter the brand to us, and we can help facilitate that with whatever arm is required. Even if you run into a customer that wants to reuse an old tool, but they want to make it safer, we can provide the arm system to make the old tools safer.
Okay.
So pretty much I get the easy gig. I spec out the tooling and then I come to Sam and I'm like, hey, listen, here's my geography that I have to work with, right? And here's my different orientations. Like, come to him with rainbows and unicorns, like, hey, can you make this happen for me, right?
Perfect. Okay. That answers that question. Now I know you guys were kind of nerding out about this, so I'm gonna let you guys take this. Tooltip tracking. You were talking about axes that could be tracked, and I just kind of stepped out of the conversation while you guys were going at it. So I want you guys to attack that. It could be either one of you. Start talking about that.
Go ahead and lead there, Sam.
So tooltip tracking, if the sequence of fastening is important. So things like a cylinder head, or maybe a wheel bolt, or a fan pulley, things.
You're talking about like in a wheel. You don't want to do it this way.
Exactly.
You want to go,
Or a cylinder head, you have to start in the middle and tighten evenly so you have even torque across your gasket. So when sequence matters, we want to track the tooltip, and what we do is we disable the tool unless the operator is on the correct fastener. So the way we do it is we have a proprietary software that's Windows-based, so I can teach you how to program it in 5 minutes. We can program that out,
maybe 10,
maybe 7.5. But we talk to the tool controller, no matter what brand it is, and we can disable the tool unless the operator is on the correct fastener. The operator has a screen in front of them. We can do a little screen right out where they're working. We can do a big screen back somewhere else. We can do whatever we want as far as displaying that information. But we can force the operator to follow a certain sequence when sequence matters. Same thing, we can go to 20 feet of reach. We can go to 7,500 newton meters and still track that tool. And the thing that is unique to us is it's Windows based, so you don't need to be a PLC programmer to program it. I'm not sure if you remember ladder logic, but I sure don't. I can't do it.
Nope.
So it's Windows based. Anybody
Slept through
can
that class.
anybody can do it. And we can track 6 axes. So we do a few things that are unique to us. when you talk about an arm, we have a shoulder joint, we have an elbow joint, we have a wrist joint.
Okay.
A lot of competitors that have tracking software, they can only track this arm joint in one direction. So you either buy an arm that does this, or you buy an arm that does this.
Okay.
We do it both ways. We don't care. Same arm does both. 6 axes, and all of our systems can be retrofit in the future. So you can buy, Aaron can sell an arm today that is non-smart. In 3 years, the customer decides, I really want to track this. Don't have to make any changes. We add encoders, you put the software on there, you're good to go. So we can add that in the future. All of our systems come standard that way, from the benchtop systems all the way up to the 7,500 newton-meter system. The other thing that we can do is the gentleman who developed and wrote the software is actually a GCI employee. We didn't outsource the programming of that. So he is a mechanical engineer and understands the mechanics of what a torque system is and manufacturing. And if you come to him with something, if Aaron says, hey, I want to do this, this, and this, I have him talk to our programmer and we can program that specifically for that customer. There's nothing that's too broad for us to do. So we have the ability for Aaron to call up our programmer and talk to him directly, not have to go through me, not have to go through 3 different countries to finally reach a programmer somewhere. We can do anything unique to a customer, whether it's barcode scanning that's unique to them, or some of the most recent ones are some quality control checks. We've put in timer delays. We put in some features that track the work instructions and force multiple checks inside of work instructions. We can link to existing work instructions. We can link to existing manufacturing execution systems, MES systems. We can link to your current line tracking system. That's all standard inside of our software.
Okay.
So,
all right. Let's talk about. We talked about standard arms also, upgrading the standard arms. But let's talk about multi-spindles. You and I have discussed multi-spindle on another podcast, I'm pretty sure.
Yeah,
I'm pretty sure. How does that relate? And what is a multi-spindle for the people that are listening? And how does that fit into solutions that you provide?
so much the same as what Sam was just speaking on, right? As far as when we have patterns and stuff of that nature. Well, sometimes, due to cycle rates and your tack times, and as well as to increase your quality, you want to run all these fasteners down at the same time, right? So we're not having to stagger them out, where I have to halfway run this one down and go through my star pattern, the famous star pattern, right? And then go through my final torque. Whereas if I have a multi-spindle, which is multiple drivers that are within a machined fixture, we're allowed to run all those fasteners down at one go, one pass, and collect all that information.
So a simple way to think about that would be having a wheel.
You got it.
With 6 lug nuts. You're not going with one driver and going around. You've got 6 drivers that go on at one time, and it actually is working with, it's a correct positioning. Yep. And it's telling each one of these when it's time to go all the way down and when it's time for final torque and in the proper order.
Right.
Okay. What are other things other than like bolts, a bolt driver? That's obviously a simple thought. But are there other things that can be applied to that? Like, drill, like drill bits, or is it usually bolts?
Typically, it's in fastening applications, right? Because at least majority of it in my industry, right? What I do say it's typically in the fastening, because drilling, although your drilling may have specific patterns in which you need to follow, for the most part, you're really not going to affect the quality a whole lot in a drilling application.
Could this be like for somebody that's doing high speed cabinetry or wood products or whatever? Could this be like a 6 drill bit application where they're taking it all in at one time? Have you seen anything like that?
We've done some drilling applications, not in cabinetry, but yeah, we've done some drilling applications. Drilling applications are a little bit tougher to justify, though. Like Aaron said, is that you're typically not so reliant on a quality aspect.
Yep.
So those customers typically are going to have a different budget than somebody who's fastening.
And we're not talking about something that's like a safety precision torque type situation or anything. Okay, I get that.
Yeah, so with multi-spindles, we've done in the wheel application like we're talking about, we've done applications where there's 10 lug nuts and we'll do 5 drivers and then have a manual rotate so they can do 5 at a time and then they rotate and do 5 more.
Okay.
We've done multiple center distances. So sometimes all the parts don't have the same distance between the spindles. So we can change the distance between the spindles. So you do product A at this distance, you do product B at a different distance. We can adjust those spindles manually. We can adjust those spindles using a pneumatic cylinder. We can even do electric actuators. We can have say a 2-spindle, for example. We can tie it into your controller. When the customer selects the correct rundown strategy, the cylinder actually moves to the correct center to center distance for those fasteners for that specific application, tightens them. Next time they select the different rundown strategy, we can automatically adjust those center to center spacing and do the next application. So we can do all the fixturing, whether it's a standard spacing or adjustable spacing, manually adjustable, pneumatically adjustable, or electronically adjustable. And the interesting thing is we've actually been asked by customers recently to design fixturing for multi-spindles where the customer in the past has had a competitor's fixture. And we found that our fixturing, because all we focus on is fixturing, we don't do torque tools. We rely on guys like Aaron to focus on the torque tool side. Our fixturing, because we know what we're doing specifically related to fixturing, is typically half the size, half the weight of our competitors, because we truly understand how those reaction forces are reacting through the system. So it's a huge advantage to your customers when line of sight.
It's a massive advantage.
Smaller total fixture, total arm, less expense, of course, but the biggest thing is line of sight and ease of use.
Yep.
You try to move a 6-spindle setup on a bridge crane, say, it doesn't move, it's not light as a feather, right? I mean, there's a lot of weight associated with it, and you have to make sure that you align yourself up. So the lighter, definitely the better, right?
Absolutely. You got to get it there to begin with.
Well, Sam was talking about the self-adjusting, and all I could sit here and think was, how to relate this over to Travis and GEMA, right? GEMA's auto positioning automatic guns, right?
Yeah.
Very much the same way, right? In the ability to kind of see what the part is, understand what's coming in. So.
Absolutely. Thank you for that.
Yeah. Well,
sense.
I always try to relate things over to paint for you when I can.
I think we've talked about this throughout this podcast, the common uses for this type of application or this type of technology. And I'm going to just read the 3 that we put down. One was critical torque. Obviously, we talked about that. Safety. I'm going to say safety as well. Torque that's basically beyond human strength. And we covered that, and then spindles. So I think we're good on that, right?
Yep.
Okay. Let's get into some examples. And again, guys, we want to not mention the specific names, but we want to talk about a couple of the case studies here. Who wants to take the first one?
Well, I was going to say one that we just recently finished for a customer was a bridge-mounted torque tube with kind of the same that Sam was talking about as far as the ability to hit multiple different orientations. So we have a free moving sleeve that has a right angle tool that's holding within, so it allows us the ability to freely come over top, run vertical down, as well as then rotate. It has an end rotation with a discrete brake system. And so what it's doing is when we're coming in at that angle, the tools want to move. So to have the ability to kind of rotate on the vertical down, we have to have some way to shut that movement.
Okay.
Right. So there's a discrete brake system that they have tied in. So we actually send a signal to a relay there that actually sees the signal for the tool is trying to actuate, and it locks that rotational ability at that point in time until the rundown is completed or the trigger is released. And then all of a sudden we have our ability to kind of orientate again.
And if that safety mechanism wasn't there, what would be the risk?
At the output of that tool at 400 newton meters, somebody's taking a carousel ride.
Yeah. All right. I get it.
We tie that circuit into the start signal. Mm-hmm. So we ensure that brake is locked prior to allowing the tool to start. So we don't allow the operators to override that. It's not possible.
Okay. All right. That's good because, if they were able to do it, they would do it.
Yep.
We've all been there. All right. So, Sam, I'm going to let you cover these 2.
Yeah, I think we talked a little bit about this. We went into multi-spindles. We've done some end of hook applications, so the fixturing is just hanging from a hoist. And it's multi-spindle fixturing that we've done recently. One was tightening a wheel, one was tightening a pulley. Different applications. We've done a 4-spindle, a 5-spindle. Some are just stationary; they don't move. The wheel application was 10 lug nuts, so they do 5 at a time, do 5, and then it's a manual rotate to get on the other 5. And those are all hanging from a hook. So
somebody is doing somebody is manually operating whatever the device is at the bottom of this, but the sheer weight of everything it's being hung by a hook. System.
Hanging from a hoist. Yep.
Okay.
Yep.
All right.
So we've done those, and the other thing that has been interesting is the electronic actuators that we've done, and tying a multi-spindle, a 2-spindle into a torque controller, so to automatically locate the different center-to-center distances. We've also done with that same customer, they're doing big industrial axles, basically, is what they're doing. So we've done applications with when they pre-assemble the hubs, before they put the hubs onto the axle, the hub is standing vertical, and we've done powered trombones as well. So we're going to tighten the nut side of the trombone with your torque tool, and we're going to hold the bolt side, bolt head side of that. And we can power those trombones, we can do a manual. So what we're doing is when you have a through bolt with a nut on the backside, as you tighten the nut, that bolt's going to want to spin.
Right.
So you have to hold that bolt so it doesn't spin, and you still get the correct clamp load onto your nut. So we've done applications like that. The one I'm thinking of was 600 Newton meters roughly. We're tightening the nut side, holding the bolt side, and that one was powered. So we're doing it with a pneumatic cylinder. After it'll get the stationary side onto the bolt head, we'll power down the trombone with the torque tool side onto the nut. Tighten that nut. When you hit torque, you can move to the next fastener.
Okay. All right. You guys got any other examples you want to talk about? I think podcast went quickly. This was good. So we're about that time. Aaron, thank you very much for joining us.
Pleasure, sir.
Sam,
Thanks for having me.
thank you. You broke your one and done record in one day filming.
Perfect.
So we'll be good. I want to close this out. Again, any questions, 1-800-334-1001. If you want to reach this guy, just call that number and ask for Aaron Osbourne. And Aaron, what's the region that you cover? What's your reach?
Central, Eastern North Carolina, Southern Virginia, and Northeastern South Carolina.
Okay. All right. You got a nice big territory.
Yeah, man. They keep me
you
busy.
hopping.
Yes, sir.
Okay. And again, the website, airpower-usa.com. And for all the podcasts and all videos, you go to airpowerairwaves.com and check us out there. I'm going to close out by saying what I always do: manufacture it a great day.
Thank you for joining the Air Power Airwaves podcast. Air Power Airwaves is a production of Air Power Inc. and Air Power Live Studios and is hosted by Travis Stirewalt. For more information, please visit airpowerairwaves.com. For more information on all of our products, brands, and manufacturing solutions, please visit airpower-usa.com. If you have any questions or need product support, please contact Air Power at 1-800-334-1001.